I'm Mario. I will be doing textbook review exercise 7, number 5 and number 7. ABCD is a triangular pyramid with angle ABC as the base and BT as the height. It is given that AC equals to 24 meters, BT is 12 meters, angle TAB is 35 degrees, and angle ABC is 90 degrees. Because it's a triangular pyramid, three triangles make this up. This one, this one, this one. ABT equals to this one, BTC equals to this one, and BAC equals to this one. So the first question, the length of AB, we're looking for this one. To find this, you just need to concentrate in this one triangle, which is this one. Using tan equals to opposite over adjacent, tan TAB, which is 35, equals to opposite over adjacent. The opposite is 12, and the adjacent is the AB, which is what we're looking for. Opposite AB. Tan 35 equals to 0.7, 12 AB, transpose 0.7 AB equals to 12 AB equals to 17.14 meters is the answer. So the length of AB equals to 17.14 meters. You can put like this, 14 and 17.14. So that's for I. And now in II, we're looking for BC, this side. To do that, we just focus on this one, on this triangle. This is the base, this one. First, we need to find the angle BCA. To do that, we use sin costan. We use sin, so sin BCA equals to, sin is opposite over hypotenuse. Opposite over hypotenuse. 17.14, which is the opposite, and the hypotenuse, which is 24. Sin BCA, this divided by this is 0.71. BCA equals to 45.57. Now we know this angle BCA equals to 45.57. But we're not done. We're looking for BC, not BCA. To get BC, we use sin costan again. We use cos this time. Cos BCA. Cos is adjacent over hypotenuse, which means it's BC over AC. BC is the one we're looking for, BC over hypotenuse 24. Cos BCA is cos 45.57. BC over 24. Cos 45.57 equals to 0.7. BC over 24. BC equals to 16.8. So the length of BC is 16.8. This is 16.8. This is 16.8. Now that's for II. Now for III, we're looking for the angle of depression of C from T. That means we are looking for angle TCB, this one. TCB, angle TCB, this one. To find this, again we use sin costan. Tan TCB, angle TCB, tan is opposite over adjacent. So in TCB, opposite would be 12 over adjacent. Adjacent would be 16.8. Tan TCB equals to this 12 divided by 16.8 equals to 0.71. Transpose equals to 35.54 degrees. So angle TCB, or the angle of depression of C from T, equals to 35.54 degrees. For number 7, 3 points A, B, and C lie on a horizontal ground. T is the top of a vertical tower standing on A. The bearings of B and C from A are 135 degrees and 225 degrees, respectively. The bearing of C from B is 250 degrees. If the distance between B and C is 50 meters and the angle of elevation of T from B is 35 degrees, calculate the height of the tower and the angle of elevation of T from C. So first, this is a triangular pyramid. This triangular pyramid is made of 3 triangles laid out here. Triangle ABC is the base, and it is represented with this triangle. The other triangles are triangle TAB. Triangle TAB is represented here, and triangle TAC, which is represented here. Now, firstly, we write down the conditions first. The first one, the bearings of B and C from A are 135 degrees and 225 degrees. So, respectively, which means this is the bearing of B from A, and this is the bearing of C from A. We focus on this triangle first, the base triangle. So this is the bearing of B from A, 135 degrees. So from A, which means we make the due north line first. B, the bearing of B is 135 degrees. So if it's from due north, turn clockwise all the way up until B, this is 135 degrees. This angle is 135 degrees. The bearing of C from A is 225 degrees. The bearing of C from A is 225, which means if you start due north and then keep going clockwise from here, you keep going until you reach AC, that whole angle equates to 225 degrees. Now, if this is 135 degrees and this entire thing is 225 degrees, only this part, angle CAB, equals to 225 degrees minus 135. That equals to 90 degrees. 90 degrees is a right angle, so we can represent that as the right angle sign. Now the second condition. The bearing of C from B is 250 degrees. The bearing of C from B is 250 degrees. So make the due north line first. The due north line from B. So if we start from the due north line of B and keep going clockwise until we reach C, this whole angle equates to 250 degrees. But remember, this is a straight line. Straight lines equate to 180 degrees. So if this entire thing is 250 and only the straight line is 180, which means this small part, this part, equates to 250 degrees minus 180 degrees, which is 70 degrees. This is 70 degrees. The next condition, the distance of B and C is 50 meters. B and C appears in only one triangle, which is this one, the base one. So B and C equals to 50 meters. The next one, angle of elevation of T from B is 35 degrees. So it's for this triangle, which is this one. Angle of elevation, it's saying angle TBA, which is this one, which means angle TBA is 35 degrees. Now this question number 7 has 2 questions, the height of the tower and the angle of elevation. We solved the height of the tower first. The height of the tower is TA. Now to find TA, we first need to find angle ABC, this one. To find this, we know that this entire angle is 135 degrees. We know that because this line and this line, they are both parallel. If they are parallel, this means this and this is equal. Now because if this entire thing is 135 degrees, that means this equals to 135 minus 70. 135 minus 70 is 65. Now that we know that angle ABC is 65 degrees, we can find the length of AB. And to find that, we use sin costan, cos. The cos of angle ABC Cos is adjacent over hypotenuse. From ABC, adjacent is AB and hypotenuse is BC. Angle ABC is 65. AB is, we don't know, we're looking for that. BC is 50. Cos 65 equals to 0.42. Transpose, blah 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 blah. And then AB, you get 21.13 meters. So this is 21.13 meters. This is also AB, 21.13 meters. Now that we know AB, we can find the length of AT, this one. We find that by using tan. Tan TBA. Tan is opposite over adjacent. Opposite of TBA, this angle, is this line of AT. And the adjacent is this line, 21.13. Angle TBA is 35 degrees. AT we don't know, that's what we're looking for. And 21.13. Tan 35 is 0.7. AT over 21.13. Multiply 0.7 by 21.13, you get 14.78. So this is the height of AT. This is the height of the tower. So the next thing that number 7 is asking us to find is the angle of elevation of T from C. That means it is this angle here. To find that angle, we first need to find the length of AC. To find that, we use sin. We focus on this triangle again. Sin ABC, which is 65, equals to, sin is opposite over hypotenuse. The opposite of ABC is AC. Sin is opposite over hypotenuse. The hypotenuse is 50, so we are at 50 here. Sin 65 equals to 0.91. AC 50. Multiply 50 by 0.91. AC is 45.32. So this we can write down as 45.32. AC, this one, 45.32. We're now looking for this angle, and to find this angle we need to find this, which we already did here. AT equals to 14.78. AT equals to 14.78. To find this angle, we use tan. Tan TCA. Tan is opposite over adjacent, which is opposite over adjacent. 14.78 over adjacent, which is 45.32. Tan TCA. This divided by this equals to 0.33. It means angle TCA equals to 18.06 degrees. That means the angle of elevation of T from C is 18.06 degrees. And the height of the tower, which is this one, is 14.78 meters.